Hello and welcome everyone. My name is Rob Williams and I'm glad that you've joined us today for today's webinar. So for today's webinar, we'll be focused on building powerful 3D models within Geosoft's GM-SYS 3D modeling software, which is an extension for Oasis montaj. GM-SYS 3D is an interactive tool for building more insightful 3D layered models with potential field data. It allows you to quickly and easily design 3D Earth models that more accurately depict the variation and irregularity of subsurface structures. So I'd like to introduce you to our presenter today, Dima Amin. Dima is a solutions consultant here at Geosoft and working in a technical capacity on geophysical applications and products in the mining, oil and gas, and near-surface industries. Thanks for joining us today, Dima.
So thanks, Rob, so much for introducing me. As you mentioned, my name is Dima, and I'm part of the technical team here at Geosoft. So today I'm going to be focusing on showing you how you can utilize GM-SYS 3D within Oasis montaj and really integrate your models and your data into a three-dimensional environment and build out your three-dimensional layered Earth model using your potential field data. So what you're seeing right now is the Oasis montaj environment, and as Rob mentioned, GM-SYS 3D is an extension that's in addition to your Oasis environment, and it ends up loading these two menus, the GM-SYS 3D menu and the GM-SYS 3D tools menu. So these two allow you to sort of create your potential fields model. The GM-SYS 3D environment is really suited for a layered Earth model, and it's really best available when you have a lot of data or lots of information. So any of these grids or kind of layers that you're bringing into your model, you do want to have that information, whether you're kind of working out other models and you've got other information that you can bring in, but these grids should exist in some way or fashion. So the environment that you end up working in is really similar to what we call a 3D map in Oasis montaj. And this is the GM-SYS 3D environment, and it is somewhat new. It actually is called a model viewer, and so the GM-SYS 3D models now in your Project Explorer actually sit as a different model document type. And you'll notice that the extension on these documents is .geosoft_GM-SYS 3D. So I'm going to try and try to bridge a bit of the gap between some of the users that may have used GM-SYS before and some of the brand new users. So if there's anything that is a bit unclear, please feel free to ask us the questions, email us at a later time, or get in touch with support. And we have made quite a few changes, so it's important to note that because in the last 2 years, I would say a lot of the changes have really happened where this document did not exist prior. So this model document environment is really where you're going to live for GM-SYS 3D. And that's important because although it looks like a map, it gives you some of the functionality of a three-dimensional map, but then the value as well with working with Oasis within Oasis montaj is that you can integrate it with all of your other tools. So one of the things you may be familiar with is GM-SYS 2D. So GM-SYS 2D, I do want to touch on quickly, although this is focused on 3D, because the integration between GM-SYS 2D and 3D does exist. And what you can do is for those unfamiliar with GM-SYS 2D, what you're seeing right now is a section profile that was built out for the Northern Alaska area that we're working with in this particular data set. So what you've got is a section, and this is a plan view, and over here we've got the gravity and magnetic data that's being modeled, and this is the depth section that's being modeled as well with the different geological units. So in GM-SYS 2D, when you're modeling, you are building these contacts and you're able to kind of interactively move them and fit the data as best as you can and add different geological units to kind of explain the data. You can also integrate these wells to kind of have different touch surfaces as well. And when you're able to do this in GM-SYS 2D, you've got that very specific section information. But then if you have multiples of these sections, I'll show you how you could actually integrate some of that information into GM-SYS 3D in a little bit. But I do want to let you know that if you've only got sort of limited line data, GM-SYS 2D might be a better fit for the environment you're working in. However, if you're working in a more data-rich environment, then the move to 3D is an natural move where you're able to not only model these horizons such as lines, but you actually are modeling them as planes. And that's what the 3D environment is allowing you to do. It's taking these surfaces here, but it's making them so that they're multiples across an area and actually building out a surface for you. So the area that we're going to be looking at here, this is a map of the NPRA area in northern Alaska. And so we've got the gravity and the magnetic data that was collected here. And the line that you see here in white, I'm just going to zoom into that, and this is just a plan map. The line that you see here is the model that I just showed you in GM-SYS 2D. So that was built because there was some seismic data available in that area, and so we were able to kind of specify the geological section in that space and integrate any type of well information we had and other info as well. But if you take a look at the map itself, we do have full gravity and magnetic data that was collected, and we also know more about this area, so we actually have grids depicting sort of geological contacts in this area. And that's a point where we're able to sort of create that GM-SYS 3D model and work in 3 dimensions. So if you just go to a GM-SYS 3D menu and select New 3D Model, you can really easily create your new GM-SYS 3D model, and the geometry grid is really what you need. And what's happening here is the geometry grid is going to depict what area you're working in and the extent of your area. So I'm just going to pick this topography grid that I have. It's also going to pull the coordinate information for you, and it's quite easy because then you can just include the base of model that you want to create, and the elevation type can either be a grid or a constant value as well. So if you just click Create, the model is created for you, and this is pretty simple and straightforward. And this is the GM-SYS 3D model environment that I spoke to you about. So I do want to take a little bit just to kind of orient you with what it looks like and what kind of inputs you would have to bring in before we kind of take that next step into showing you a model that's already been built up. So all of these icons here should look familiar. They're all the same as what a 3D map would include. So these are prefixed views and different kind of, here you can kind of rotate or pan through. And you've got the zoom, so very typical what we're used to. And then what we have over here is the Model Explorer. And the Model Explorer is quite similar to the Project Explorer, but specific to your model environment. So within the Model Explorer, you've got the Layers, the Survey, and the DDT tabs. So the Layers is where you're going to be building out your model. Some of these might not be in the current version that you have, such as the bodies. That is something that we're currently going to be supporting in 8.3. So within 8.3, you'll be able to take a look at and incorporate bodies into your GM-SYS 3D model. And those are going to be closed bodies only for the time being. So the Layers tab is where you bring in your layers, and for every layer that you bring in, right now we just have the topography as we just started our model. You have the Attributes tab here, and then you've also got the clipping. So very familiar to us in Oasis, the clipping is now supported in GM-SYS 3D, so you're able to clip on different angles as well and different orientations and in the spatial environment here. And when you're on a layer, the properties is where you're really assigning the different values that you have for this area. And so when you're assigning properties for a model, you're assigning the properties of that model for that top layer onwards until the next layer. So right now, because I only have that one layer, any properties that I assign in this particular model would be assigned to the rest of it. We have the functionality of forward modeling in GM-SYS 3D, so if you wanted to just bring in a simple survey and actually, or a simple model and forward model it, you can certainly do that in GM-SYS 3D, but we also have some inversion capabilities that I'm going to discuss shortly as well. So this is the basic environment, and in order to just get a better sense of what kind of information you can bring in, we're going to take a look at the model that's been built out a little bit already. So these layers here have been included into the model. So we've got the topography and then the sea level topography, and then we've also got some other layers and then the basement in there as well, and the moho. So if I just click on the topography layer, for example, the topography layer here has a density that's been set for 2.35. And you can model gravity or magnetic data, and so we have those two different capabilities, but for this particular model, what I've included is a gravity survey. So this is a free air gravity survey that's been added as a survey, and you would just simply do that by going to the survey menu, gravity, and then add survey. And likewise, if you were incorporating your magnetic data, you would do the same through the Survey Magnetic Add Survey menu. So the Survey tab is where it shows you what kind of data you're incorporating. In this case, as I mentioned, the free air. And then the layers is where you're going to be taking a look at all of the different layers in your model interactively, all at the same time, and then you can also kind of turn things on and off within the environment. There are a few times where you're going to want to come out of the model viewer, and I'll show you those. That has to do with taking a look at the grids as well as the databases to better understand how your inversions are working. So what I've got here under layers is all of these different layers, and so if we look at the Schublick layer, for example, the density has been set as 2.65, and I just want to point out here that in the drop-down you have the capability to set a lateral distribution, which if we click on, you can set as a constant lateral distribution or a grid. And so if you have a grid, the density grid that is showing you the lateral density distribution, you can set it here and that'll actually apply it to that layer. So over here for the density type, and these parameters would also be the same for the susceptibility, you also have the voxel distribution option. So this is a great way to add a voxel. So in this particular case, I've got a voxel already loaded, so it's showing you the voxel distribution. It isn't showing you what the actual voxel looks like here, but we'll take a look at it once we load into a 3D map. So when you pick a voxel distribution or a lateral distribution, it does show you the density distribution with the mean, max, and median, and the standard deviation here. And this would do the same for the susceptibility as well. So things are interactively set for you to be able to get as much of the information as you need while you're within the model viewing document, as opposed to having to come in and out as you require different information. Within the layer as well, the attributes and the clipping properties that are down below here, the attributes gives you the elevation differentiation of the actual grid that you've got for the relief. So it's important to note that with any layer that you have, this is a relief surface that's depicting a contact surface between the geological units. So you're setting the properties between the layers, and that's why you can set that property using a voxel or a constant value as well. And when you're setting those properties, you can invert on the location of that layer as opposed to just, the values themselves. So for the Schublick, we only have the one relief surface, so it is just highlighted as the relief surface there. But for the basement, as we started to sort of invert and take a look at our results, using the structural inversion, I was able to actually have several different relief surfaces. And you can turn these on and off to be able to view which ones were the last ones that you ran. This is a new feature that's coming out, so if you haven't seen it yet, this is kind of a sneak peek as to some of the changes that we're making to make things a little bit easier for you. Again, so that you don't have to continuously go in and out and change things and undo things. You can just right-click, back up your relief surface that's active, and you'll notice whichever one is bold is the active one. So you can just right-click and then back up the relief surface, or export it if you're happy with it as well. And then when you activate it, you can choose to run further structural inversions as well and see what works and what doesn't. So having said that, when you're working with a structural inversion, so again, this is in this case the basement that we're looking at, but the basement still has the properties and the attributes and the clipping. But when you're running a structural inversion, you would go to the Calculate menu, and then you would choose Gravity Structural Inversion there. You also have the lateral density inversion and the constant density inversion, and as I mentioned earlier, you still have the forward gravity functionality. I want to quickly point out the Vellum button here. This is also a new feature that's going to be released within the GM-SYS 3D environment. And Vellum is a specific type of structural inversion. And what it's actually doing is it's using our cloud computing power to run and resolve a gravity inversion that's specific to the base of salt. So you'll see more information coming up on this. Vellum is a specific type of structural inversion that uses the cloud technology in order to run. But your other structural inversions are under the Calculate menu, and you also have the forward magnetic inversion and the magnetic structural inversion, lateral susceptibility, and one-step susceptibility inversions under here as well. Like I said, the different reliefs will now be activated for you in 8.3 as we release that in the coming release, and you have the capability to be able to turn things on and off in that way. When you do that, you want to keep in mind that when you're running these inversions, you do want to look at what your gravity error and versus your observed looks like. And when you run inversions, you do have the option to then run the forward to be able to see what your grids look like. So the gravity calculated versus the error versus the observed, you can kind of see as the errors is not kind of reduced very much, the model is not fitting your data, and you can, this is a very iterative process. It's not something that just is a one-step kind of solution. You do have to know a lot about the area, and you do want to have a data-rich environment where you can go back and forth. So the grids provide that information. And then the databases also gives you, as you run inversions, it gives you the errors and the maximum and the mean. So you do have those two options as well, not only by looking at the actual relief surface that you generate within the 3D environment, but you do also have the grids as well as the error calculation that's in the database to compare and be able to see what you're doing. Another thing that we've added in this coming release is being able to apply bodies to closed bodies. That should specify closed bodies are going to be supported in the next release. And that's that little red blob that you see there. So if I just kind of zoom in, that red body was actually built out using the GM-SYS 2D sections, and it was using the GeoString wireframing capabilities that all Oasis montage users have to actually create this closed body that depicts a magnetic feature, essentially. So if you have, voxels and voxels that are specifying smaller bodies and things, you can certainly still use those. And like I mentioned, that's just in the drop down for the properties of the different, whether it's density or susceptibility. But you can also include these small closed bodies where you can specify a specific susceptibility or density. And I want to show you how this was sort of created, just to sort of help close the loop between the GM-SYS 2D and the 3D world. So to include a body, you would just right-click and add body, and in that menu you would see that it is a geosurface file that's supported. So I'm just going to click back into a GM-SYS section to kind of show you how that's built out. So if we open up a GM-SYS 2D section, this was essentially extracted just as a vertical section from the GM-SYS 2D models that I showed you. And when you're building out these, you would use this wireframing tool capability, and if any of you are particularly interested in that, we can certainly get you step-by-step instructions on how to create the wire strings. In the interest of time, I won't go through this step-by-step, but essentially what this allows you to do is to digitize this black line that I've digitized before, and when you digitize them on these lines, you can then connect them in a 3D environment to build out a closed surface, which is a great way to be able to incorporate kind of small bodies and that detail that you have from the 2D sections. You can also, if you have a lot of 2D sections and you want to create that two-dimensional plane, you can also use the wireframing here to actually click on the surfaces and then create sort of that layer or just grid out that layer as well. So that's the connection into the 2D space, the GM-SYS 2D modeling. And although the three-dimensional environment does give you quite a bit of capability in the clipping and the transparency and everything that you're used to with regards to excuse me, with regards to things that you're used to just being able to turn on and off and use the clipping. So it's great that you have all of those capabilities, but at the same time you might want to export things out to a three-dimensional map environment where you might be more comfortable. So to export, under the display menu in your GM-SYS 3D environment, you can export the layer surface grids, you can also extract 2D sections, and you can also extract a GM-SYS 2D profile model. So again, that workflow allows you to kind of go back and forth between the environments. Exporting into a 3DV file. A 3DV file is native to Oasis Montage, and what it allows you to do is export all the different components into a 3D map, and then you can just open it up in a 3D map, which is what I've done here. So let's take a look. This is a full three-dimensional map that I've incorporated. So I've incorporated quite a few things, and as much as the actual modeling is not a sort of quick one step, you know, you run one inversion, you get the perfect results and you're done. The actual inversion and modeling process is quite a back and forth iterative process, and that's why we really want to make it easy for you to incorporate all the data together into a three-dimensional environment and to have all the maps and all the pieces work together easily, because we know you're spending that time thinking about whether the modeling makes sense and whether the geological bodies are sitting where they need to. We know that's going to be an iterative, longer process, so we spend a lot of time making things easier for you when you're incorporating all your information visually. So what I've got in this map is I do have a voxel that's showing the density distribution. I just have the transparency set, but if I sort of increase it, you can see that that voxel was also exported out from a model that was complete. Just going to turn off the voxel just to make things a bit more clear. So you've got that density distribution in the voxel. I also have some drill holes that I had available, and you can also, through GM-SYS 3D, use the constraint builders to incorporate whether it's drill hole data or seismic data into your model. So you build out constraint grids, and you can incorporate them into your structural inversions as well. So that's important to note. What I also have here is those sections that I was telling you about. So in this particular section, this magnetic body was the one that I was joining between the two. And so you've got that body being joined from this section to the other using those wireframing tools. And I'm just going to turn on the wireframes so you can actually see without the body what it looks like. It's these little bodies that were interpreted off of my GM-SYS 2D sections. And you can link them up as you see fit and as you use your own interpretation skills to be able to link up those bodies. So those sections are also available in my 3D environment. I've brought them in, and of course the layer grids are all in here as well, all the different surfaces. So I was able to export all the layered surfaces and the closed body and anything else that was in my model document into a 3D map, and then I was able to quickly add the drill holes and some of the other sections and information into my model to be able to see it a little bit better visually. And as you go back and forth, again, you're able to incorporate that information from your GM-SYS 2D models into your GM-SYS 3D models, and hopefully we've made it a bit easier for you within the GM-SYS 3D environment to go back and forth and make sure that your model fits. That's GM-SYS 3D for you, so hopefully we've been able to give you a little bit more of a sort of workflow or a bit more of an impression as to how you can use the GM-SYS 3D tools to better incorporate some of your 2D information. And if you do have any further any questions, we're going to go through a few right now, but then you can certainly get back to one of your Geosoft representatives with regards to any specific questions or issues that you're having. Support's always available. I want to remind everyone of that, and we're more than happy to answer anything. I'm just going to hand it over back to Rob. We do have a question with regards to the drill hole information that I just showed in the other map, and the question was if that's incorporated into your structural inversion. So the way that the drill hole information is incorporated is actually through constraint grids. So if you go Under grid editing, you have the constraints building capabilities for well database as well as from a database line, which would be more applicable to a seismic line. So you can create those grids and actually apply them as constraints. So when you go to the calculate and then gravity structural inversion, you do have the option here to include a constraint grid. And so once you're in there, you would pull that grid that you built and incorporate it in that way. So there's no direct way for you just to load a drill hole database into your model and then just have the drill holes match up and line up the information. You do have to create those constraint grids independently. And I think that was actually the only technical question that we had. There's some few other kind of logistical things for further information that we're going to get back to the individuals about. I just want to say thank you guys so much for attending. We really appreciate it. And again, don't hesitate to contact either myself or Rob with any further questions, and we'll get back to you with them as soon as we can.